Hello, I'm Andy Welton, and I'll be guiding you through this primer on how to defend, respond, and recover water utility infrastructure from wildfire damage. A number of different wildfires are happening across America's West right now. The incidents are not yet fully documented, and responses are still going on. What I'd like to do is give you some advice based on past wildfire incidents that have damaged water utility infrastructure. Two issues can occur. One is physical damage of the infrastructure. Water tanks, hydrants, meter boxes, service lines, water meters, valves, all can be damaged. You can have leaks, you can have breaks, maybe the meters don't work properly anymore, and this can be due to fire damage or other objects falling upon these infrastructure and causing physical damage, or heat. Heat can cause warping and other types of material responses that cause these products to not work properly. Another form of damage is chemical contamination. And this is where chemicals get into the water system, or they're formed inside the water system during the fire, and then they basically diffuse in or out of your infrastructure. And that is problematic because if you flush out contaminated water and these chemicals that are floating around in the water, and you put clean water in there, you can have your infrastructure, if it's still contaminated, make that water unsafe. And so this is a relatively new discovery in the last several years associated with chemical contamination, damage of infrastructure. Specifically, what we're thinking about, what we know are present, are these compounds called volatile organic compounds and semi-volatile organic compounds. These can be present in damaged drinking water distribution systems after fires. The exact sources of these compounds, it has not yet been confirmed. There may be multiple sources in a single water utility distribution system. They can be materials from forest fire burning. The material goes into the air. It can be sucked into a depressurized water distribution system. Materials from structure fire burning, and those materials may be sucked into a distribution system, or they may backflow through the water main, or they may be the decomposition of plastic materials in place in water distribution systems. There's a number of plastics out there. It's not just plastic pipes. So there's plastic used in meters, there's plastic used in valves, there's plastics in gaskets. And so plastics can be many places, and heat damage may cause them to generate VOCs and SVOCs that can contaminate your water. Now, if the water distribution system does not have plastic distribution system components, you still can have contamination. And that's why you have to hunt for it. Meters, valves, pipes, gaskets, and buildings all, as I mentioned, contain plastic infrastructure. So you need to think about testing appropriately. Now, chemicals can sorb into and leach from water utility distribution systems and plumbing components. In order to find contamination, you have to do what's called stagnation. So you have to fill up the asset and allow the water, the clean water, to sit there for a certain period of time, and then sample that water. So if you don't allow that to happen, you won't have enough time passed for the contaminated infrastructure to leach chemicals out into the water, go into your water sample, and that you send to the lab for analysis. Now, this is a video that we've shown contamination. We have carbon compounds that penetrate plastics. And then what we have is fresh water coming into the pipe, but the infrastructure then leaches some of those plastic compounds into the water, and that causes contamination. Now, damage you can see after wildfire can span the spectrum of shocking to you can't really see that the infrastructure is damaged, but say the water meter doesn't work anymore. So what we have here are meter boxes, which are highly vulnerable to wildfire because they are exposed. They are not 2 feet underground where the heat wouldn't get to them. And you have service lines. Sometimes meters and service line materials melt. They flow down the pipe and then they cool and reform. And you also see charred meters. You can have metal meter, you can have plastic meters or metal meters with plastic components. So there's a whole bunch of different types of damage you see. Plastics, as I mentioned, can melt. Melt just means flowing, doesn't necessarily mean generating contamination. But when they burn or combust, that releases VOCs and SVOCs. So after you have a situation where you've lost water service, what you may see is your building owners, commercial and residential, go out and buy these plastic tanks and hook them up. Some meters do not survive wildfire damage. Some of them look fine, but when you try to use them, they don't work anymore. In others, as I mentioned before, plastic pipes may melt, or plastics in the system may melt, flow down the pipe, and then cool and reform. And so you may not be able to see the damage just looking at the exterior of a plastic pipe. You will have to do chemical testing to see what type of contamination exists. And then in this situation, they open up the pipe. Now, where is the contamination coming from? As I mentioned, there's generally 3 different scenarios. The first is basically degradation of the plastics by thermal exposure. So you heat these organic materials up and they release chemicals after they've generated them, and they release them directly into the water. You can have forest biomass or forest fire combustion. They do release VOCs and SVOCs into contaminated air, which can then get into water utility distribution systems. And then also, of course, structure fire burning. So structures, residential and commercial structures that are burning may release these types of VOCs and SVOCs, and then those might also either backflow through the water piping network into the piping network and then spread out into the distribution system, or they may get sucked in through the air. Now, risk management for drinking water systems is very important. What can you do to better manage the risk? And there's really 3 conditions you need to think about. The first is preparation, the second is response, and the third is recovery. And specifically in preparation, what you want to do is identify your vulnerable facilities and operations. For example, infrastructure that's near or at ground surface is exposed and vulnerable. Plastics can be in meters and meter boxes and a whole bunch of different materials, and so identify those locations. If you have a certain number of service lines or meter boxes that are plastic, whereas others are metal and concrete, that's important to know. Develop a sampling strategy for VOCs and SVOCs. Don't just look for one. Don't just look for benzene. Your intent after the fire is to figure out as quickly as possible if there is contamination in your water system, what it is and where it is. And once you do that, and if you do that thoroughly, then you can march through your water system to validate either that you have contamination and you need to get rid of it, or that you don't have contamination. But if you don't test for the right chemicals, the chemicals that could be present, then you will basically hamstring your response. And if somebody finds these other chemicals, that will cause your entire response in terms of public health protection to fall apart. So it's very important that you look for VOCs and SVOCs. Another thing you have to do is call the laboratories that you're going to use. Do they have the ability to process 100 samples if you were to drop them off? Do you have the supplies on hand to collect 100 samples? You may need specialized expertise too, depending on how complex the damage is to your infrastructure. Because sometimes non-standard EPA method chemicals can be present and pose a health risk to you. So the laboratories may not necessarily look for them, but that is something that you may need help with. And you can always call myself or other people for help. Verify mutual aid support exists. Talk to the WARN in your state and get them ready to help you expedite sampling analysis, shut off your system, and stabilize it. Review shut-off isolation protocols with the fire service and coordination plan. You do not want to shut down your water system without coordinating with the emergency management and fire service, because if the firefighters come in and try to protect homes or other infrastructure and they go to the fire hydrant and it's dry because you shut it off, that's a problem, right? So you are there as a utility to help support life-saving and property-saving services by the fire department. That is your support function once the fire department shows up. Identify assets at high risk from wildfire and your ability to operate remotely, including shutdown protocols for different assets. So can you monitor your system outside the area? Do you have to be in the plant? Do you have to be on an internet connection? I mean, what types of ways can you communicate and understand what's going on with your system? And you should also prepare what's called a do not use order notification. So a do not use order notification, and I'll talk about in a second on another slide, will restrict water use to firefighting and toilet flushing only uses. And this is important for reasons I'll tell you in a second. So finally, determine if fire and EMS agencies permit any water utility employees to remain to support firefighting. So do they want everybody out? Or do they want a couple utility folks to stay around just in case they have issues with the water system that they need help with? There's dry hydrants, there's main breaks, they don't understand certain assets, and so make sure you're communicating and coordinating with the emergency management agencies. And then finally, determine if any assets can be remotely controlled or monitored. And so again, this is what can you do from afar, outside the zone that's being attacked by fire. Number 2, from a response perspective, when fire is in your community, you need to protect your own life. That is the most important action that you have to take, because if you are incapable of providing help to other people, then everything else doesn't matter. So it's very important to make sure that you protect your own life here. Keep water directed to firefighting areas. Again, coordinate with emergency management. Make sure these individuals know how you can help them and if they need help, if they expect you to help them in any way. Isolate system segments based on coordination with emergency management. And it is essential, again, to coordinate with fire service to maintain life and safety protection. Address water main hydrant failures and isolate and repair them, or shut down certain parts of the system that start leaking. And so this is basically to prevent widespread depressurization, because when widespread depressurization happens, you have basically water sloshing around the system that may actually be contaminated and contaminating all sorts of infrastructure that was not contaminated before. Number 3, response. When the fire's out and the evacuation order is lifted, again, you need to protect your own life. Be careful around the system and the community, because you'll have potentially burned vehicles, you'll have glass, you'll have all sorts of hazards that are there, and it's very important to protect yourself. You will want to issue water use restrictions if the fire is near, if heat came towards your assets, not just it burned or didn't burn, but if heat radiated towards your assets, you could have damage. If it entered the community, you definitely need to issue water use restrictions. And a do not use order is the most appropriate to protect the health of your population from VOC and SVOC contamination. And why that matters is because VOC and SVOCs are toxic. They can be present at levels that exceed hazardous waste thresholds in the drinking water, and they are not easily detectable sometimes by odor. So hazardous waste scale contamination can be present, and you need to basically prevent your population from you coming in contact with the water at all costs. Do not drink, do not boil orders allows bathing and washing dishes and other types of activities. That is not recommended, because again, if you have hazardous waste scale contamination in the drinking water, like what was found after the Tubbs fire in Santa Rosa, or like what was found after the Camp Fire in Butte County, California, you will be allowing building owners to draw in that contaminated water, contaminate their plumbing, and then contaminate potentially themselves and have acute adverse health effects, or contaminate their dishes and other materials. So that is not recommended. A boil water order is not recommended either if any of these conditions exist, because you would recommend to people boil their water so they'll heat it, and VOCs leave the water and enter the air. So you would actually increase a person's exposure to chemicals by telling them to boil the water that's chemically contaminated. Another action you should do is collect water samples and send them for expedited analysis for VOCs and SVOCs turnaround. That's why it's really important that you find laboratories that can help you, and you want a 24-hour turnaround. If a laboratory tells you, well, they can only do 7 days or 3 days, well, you should talk to multiple laboratories, certified laboratories, to find out who can really help you in this time of need. Request emergency water supply from the State Drinking Water Primacy Agency if you issue any of these advisories, and you should invoke that water use restriction. You want to flush your distribution system, especially if you've depressurized any parts of it, because that means that potentially organic chemicals like VOCs and SVOCs have gone into the system, and you need to get them out rapidly. The longer that contaminated water sits in there, the longer those chemicals have a chance to diffuse into the infrastructure, and it will take much, much longer for them to come out. So you can think of this as a sponge, and if we put red dye on that sponge, it will absorb into it pretty rapidly. But if we leave it there for a very long time, that red dye may spread out into the sponge, and when we try to wash that sponge, it's going to take us a long time to get that all out because it went in so deep. We also want to keep water directed to firefighting areas. You want to continue this communication with emergency management, because emergency responders will be trying to still protect life, protect property, and potentially protect your life in this. So you want to make sure that they have the support they need. Address water main and hydrant failures, and you should prioritize these. And your maintenance staff and distribution crews will be able to kind of prioritize these. Shut off water meters to burn properties. Basically, if you have water systems affected by fire and homes have burned down, you may have water running on properties. And that's kind of like bleeding out of the system. And so you need to stop that, stop the bleeding, and try to keep pressure in the system so that you can prevent contamination from coming into it. And finally, enact mutual aid. Call in water sampling teams. Call in distribution repair teams. If you have gotten your logistics in a row, WARN, the system, can enable people to come in and help you. Other utilities that know how to take water samples. Other utilities that know how to repair hydrants or pipes or breaks. These teams are tremendously valuable, and this is utilities helping utilities. Now, I've mentioned WARN a couple times. The question is, do you know how to activate WARN? The American Water Works Association has some information available on their website, and each state and territory has a WARN group. And so if you have any questions about this, feel free to contact Dr. Kevin Morley, the Emergency Preparedness and Security Manager at the American Water Works Association. He's involved in disasters across the U.S. and territories and gets called a lot from utilities and communities that are in need. So what to expect with wildfire? Wildfires can cause significant water infrastructure contamination. VOCs and SVOCs can be present. Levels can exceed hazardous waste limits. After the Tubbs fire, 40 parts per million, 40,000 parts per billion of benzene was found in Santa Rosa in some samples. A do not use order should be issued. And as you recover, keep in mind, you need to protect homeowners and their plumbing from damage. And your homeowners and plumbing and your commercial building owners are all going to be looking to figure out how fast they can recover. When can they go back to normal? When do they not have to worry about the water not being safe again? And the way you do that is you blanket your distribution system with testing. You test for VOCs and SVOCs to either detect or rule out the potential for water contamination. And testing is not a few samples, you're talking quite a few after the contamination. Some more of what to expect. You can download this study that came out in the year 2020. It's free at the AWA Water Science Journal. And just to kind of give you some background, what I've done for my career has been disaster response in support to utilities, communities, homeowners, government agencies. I worked for the U.S. Army, helping units deployed understand how to respond to potential water contamination incidents. I've also worked with military installations on understanding how to identify threats and also respond to water contaminations. And in the civilian sector, I've done that as well. And so we also educate, we talk about things, we respond on site, and there is just a number of different opportunities for you to learn about water infrastructure, contamination, decontamination, and how you can support your community's need. All the information can be found at our website at plumbingsafety.org. All sorts of information there, and I will be posting this video on YouTube. And with that, if you have any questions, please let me know. Please feel free to contact me, and I hope that this presentation was helpful.